I'll just wait patiently. All right, recording has started. All right, so this is Tuesday. This is a Unit 2 review with me. All right, let's get started. We're going to probably go pretty quick through this. We have a total of 17 slides. Three of them are about your TGA, and then one of them is obviously the password. So whatever that math is. Okay, terminal ray. So we have to determine what quadrant the terminal ray of the angle drawn in standard position lies in. So standard position is the initial ray, I think that's what it's called, right? Is on the positive x-axis. So 26 pi over 9, how do we find which quadrant that is in? So multiply by 180 over pi, yep. So I think that's probably one of the best ways to do it. Most people think in degrees and not radians. You could actually convert it into a decimal, and if you're good at knowing that a full rotation is 2 pi, if you convert the fraction portion to a decimal and you're good at looking at a decimal in comparison to a full rotation being 2, that works too. But generally speaking, I think degrees is probably the easiest. So multiplying, if it's in radians, multiplying these by 180 over pi to get the degree. So 26 over pi, that is, oh, I've written down somewhere. That's 520 degrees is what I have. So yeah, 520 degrees. And to find the coterminal angle, we would just do what? So if that's 520 degrees, what should I do? Yeah, subtract 360. So if you subtract 360 from that, we get 160 degrees. So let me get my my pen out. So that is 520 degrees. And we just, to find the coterminal, so it's easier to look at, we just subtract 360. And what did I say? It was 160 degrees. So looking at 160 degrees is much easier than looking at the radian or that 520. So what quadrant is that in? Yep, that is quadrant number 2. So quadrant 2. All right, negative 95 pi over 36. What is that degree? Negative 475 is correct. So this is negative 475. And what should I do to that to make it look easier to look at? To find the coterminal. Yep, add 360 twice. Yeah. Adding 360 once isn't going to be enough to make it positive. So we're just going to add 720, or you can add 2 times 360, or just type in plus 360 twice. It's the same thing, right? And then we get 245, I think. So that's the coterminal angle, and that is in quadrant 3. Yeah. Yep. So I'm just gonna write the answers for the next 2. So the third one, that's gonna be quadrant 4, and then the last one is going to be quadrant number 1. And I'll leave it up to you to figure out those degrees. Okay, next kind of problem here. All right, what is the reference angle alpha for the given angle measure drawn in standard position? All right, so what you want to do is probably convert these into degrees first. That would probably be the easiest if it's in radian. And then draw a picture. So negative 17 pi over 18, that is the same thing as negative 10 degrees. So if I was to draw a picture, that's going to be here, right? That's negative 10 degrees. So remember, reference angles are angles formed by the I'm drawing a blank of the vocab word of the is on the previous page. Why is word so hard this morning? Terminal ray. Terminal ray. Yeah, so reference angles is the angle made with the terminal ray and the x-axis. That is important to remember. Oops.
Sarah's asking. Oh, you got it.
What's the question?
Sarah's asking if you can go back to the last page, please.
Sure. Good. All right, so there is in one of, I think in 2.05 day one, I'll let you all go back to that lesson. There is a page that has the formulas to calculate these reference angles. So this one is going to be just 10 degrees. And visually you can see that. If I go clockwise 10 degrees, well, the angle made with the x-axis is 10 degrees. So that one's pretty easy. You don't really have to think about the formula. I like drawing the picture. I think it's easier than doing the formula method. I think the pictures make more sense to me, at least. But I'll let you decide how you want to do it. All right, then the second one here, 10 pi over 3. I like converting that into degrees, and that is 600 degrees. Well, you want to get that, the coterminal angle, we want that to be in, from 0 to 360. So we want to find the coterminal angle. So we subtract 360, so we get 240 degrees. So that tells us it is in quadrant number, that's quadrant 3, is that right? Yeah, quadrant 3. So I'm going to draw a little picture to kind of represent that. So here's my my circle here, quadrant 3. We'll say it's right here. And then if you want to just draw the circle around there, that's more like an oval, but it's okay. So the reference angle is this angle right here. So let me change my colors here. So from here all the way to here, that is 240 degrees. So you want to look at your formulas. To find that little blue angle that I drew first, we want to take 180 minus that 240. That's the formula that's from that lesson. And drawing a picture, that's how I derive it, by drawing a picture. I don't look at those formulas. I think it's better to understand what's going on versus memorizing just a mindless formula. And then that's how we get 60 degrees. So that blue angle that I drew, the reference angle, is 60 degrees. Converted back to radians is pi over 3. All right. Next one, 5 pi over 3 converted into degree is 300 degrees. That is clearly in quadrant number 4. So I'm going to draw a picture to show that. Oops. So 300 degrees is in this quadrant here. So there is your reference angle that we want to calculate. And so the degree given is from here all the way to here. And that degree is 300 degrees. So just looking at it visually, it should be pretty easy to see that that blue angle is just going to be 360 minus the 300. And that's what the formula says too from that lesson. And then that's how we get 60 degrees again. All right, last one on this page, 11 pi over 4 converted into degrees. That is 495. Coterminal angle, subtract 360 to get 135. So 135 is in quadrant number 2. So I will draw a picture to represent that. Let me use blue first. All right, quadrant 2. So we'll just draw it like this. And then the reference angle is this angle right here. All right, the given angle is 135, so I'll do it in, I think it's red. So from here to here, that is 135. So if you go back to the formulas from that lesson, the formula to find that blue angle, the reference angle, is going to be 180 minus that red angle, 135. And that's how we get 45 degrees. Converted back to radians is pi over 4.
Emily was asking if you could explain how you got 10 in the first one.
10? Yep. So Emily, I think you showed me this to convert that negative degrees into a positive coterminal value. Get my pen tool out. So that negative 110, or sorry, that negative 10 degrees, we want to add 360 to it. And that's going to be 350 degrees. So that means from the starting point all the way around is 350 degrees. Now, if you look back at your formulas from this lesson, to find that blue reference angle that I already have written as 10 degrees, the formula is 360 minus theta, and theta being 350, and that's how you get 10 degrees. Yeah, the reference angle is not minus 10 degrees. The reference angle for that first one is a positive 10 degrees. So reference angles can only be positive from like 1 degree up to 179 degrees. Yep, go ahead. The mic is there for all of you to use.
What I'm confused about is converting the negative 17 pi over 18. You would get negative 170, not negative 10, and then negative 170 plus 360 equals 190, not 10.
Whoa. Wait, so you're saying negative 17 pi over 18 converted into degree isn't 10 degrees?
Oh.
It's not?
No.
Oh, well, that's the problem. I don't know how to do math. Well, that makes a lot of sense. So, of course I'm wrong. Hold on. So we're going to start this problem over. If I only knew what was going on. All right, let me change. Let me just. Dun, dun, dun. All right, let's redo this one. All right. So here's my trick, guys. To erase stuff in new row, I just put a white box over it. Genius, I know. Okay, Emily, what is...
There's an eraser tool.
It doesn't work that good. I've tried it. Negative 17 pi over 18. What is that in degrees?
Negative 170.
Okay, negative 170. Okay. Coterminal, so we add 360 to it. And what do we get?
190.
All right, 190. All right. And 190 is in quadrant number 3. So like this. So we want this angle here. And I'm going to switch colors. So that's 190. So we want to do 180. So the reference angle is equal to 180 sorry, not 180, 190 minus 180. And then, well, that's funny. I got the same answer. You know, I must have done that problem a really weird way, and that's why my numbers made no sense. You know, I'm gonna look at that later and figure out why I did what I did, but I got 10 degrees still. But it makes sense now of why I got 10 degrees. That's what's important. I mean, wait, no. Ah, okay, so we good now. Pictures are good to draw. It helps. All right. Let's try to go a little faster from here on out. I think most of the stuff I actually have written out or typed out. Hopefully it's all right. Okay, this one. All right, everyone, what's sine of 5 pi over 4? Negative radical 2 over 2. Yep. So remember, sine is y, cosine is x, and then tangent is y over x. All right. So what's cosine of 3 pi over 2? Zero. Yep, it is 0. And then tangent 5 pi over 6. Well, we have to do a little bit of math here. We have to put the y value, which is a half, divided by the x value, which is negative radical 3 over 2. Flip and multiply. The 2's cancel out. And that's how we get negative 1 over radical 3. But don't forget, we can't have radicals in our denominator. So we have to rationalize by multiplying by rad 3 over rad 3. Don't forget that step. And that's how we get negative radical 3 over 3. All right, we good on this page? We had basically 2 days of this lesson. The last 2 days. Use your unit circle. All right. We want to find the exact values. So we got more problems. All right. So rather than the fundamental trig functions, we have cosecant, secant, and cotangent. Cosecant. Cosecant is 1 divided by sine. So it's 1 over y. So again, cosecant is 1 over sine, so it's 1 over the y value. So when you have negative 4 pi over 3, 4 pi over 3 is here. So one thing we can do to this is we can just add 2 pi to 4 pi over 3 to get the coterminal angle. So we want to go negative 4 pi over 3. So 240 degrees. So we're going negative 240 degrees. That's going to put us here. So this is negative 4 pi over 3. But again, if you want to convert this into a positive value, you just have to add 2 pi to the radians to get the coterminal radian angle, which is 2 pi over 3. And that's how I have 1 over the y value, radical 3 over 2. And then we flip and multiply. 1 times anything is itself. We need to rationalize 2 over radical 3 by rad 3 over rad 3. And that's how we get 2 rad 3 over 3. Yeah, there's different ways to kind of approach this kind of problem, but you need to use your unit circle. Now, on this previous page, you all could have just typed these in your calculator to get the answer. But you need, if you're going to do it that way, do it both ways. Use the unit circle and then type it in, because you need to know how to use the unit circle, because we're going to use this in the next 2 units, and it's important that you understand how to use this unit circle. So don't neglect it. All right, secant of pi. Well, secant is the same thing as 1 divided by cosine, or in other words, 1 divided by x. So we go over to pi, and it's going to be 1 divided by 0. Uh-oh, that seems like it's going to be a problem. 1 divided by 0. Oh, sorry, that's the y value. I pointed to the wrong value. The x value is -1, not 0. It's x comma y, if you've forgotten like me. -1. So it's 1 divided by the x value. So 1 divided by -1 gives us -1. And the last one on this page, cotangent. Cotangent, same thing as 1 divided by tangent. Or in other words, this one is cotangent is, well, tangent is y over x, so cotangent is x over y. And I would think of it that way and do it that way. So cotangent is x over y, so 7 pi over 4. 7 pi over 4 is here, 315 degrees. So we're doing x over y. Well, a number divided by the same number but negative just makes it a -1, right? Hopefully I probably showed work. Yeah, so this step right here, all of you should know a number divided by itself is going to be 1, and a positive divided by negative, it just makes it negative, so it is -1. You don't have to show that middle step that I did here. I don't think anybody should show this step. I just did it for funsies. All right, so that was the last 2 days of lessons. Okay, think way back, 2.02 day 1. So converting from DMS, which is decimal minute seconds, to decimal degrees. I'm sorry, degree minute seconds to decimal degrees. All right, so recall how to do this, anybody? All right, Emily, how do we do it?
So first you take the first part of it, not counting the decimal, 22, which is the degrees. Then you take 0.09, multiply it by 60 to get 27 divided by 5 or 5.4. And then you take so 5 is the minute, and then you take the 0.4 and multiply that by 60. So 0.4 times 60, you get 24, and that's the seconds.
Perfect. And you just put it all together. Pretty easy stuff. I think these are freebies. They should be. So let me just show the work for this last one real quick. 0.12 times 60, 7.2. 0.2 times 60 is 12. Put it all together. 34 degrees, 7 minutes, 12 seconds. All right. Anybody want to explain how we find the DMS from decimal degrees? Nobody wants to explain this one? Go for it, Antonio.
Don't you just do the opposite and divide 36 by 60? And then take that decimal and then do that.
There's an easier way to do it.
Okay, then I'm off the mic.
Yeah, you got to be careful about doing like 36 seconds and dividing that by 60. It gets doing it that way. You create more steps, and I didn't teach it that way, and it actually is a lot harder. I'm not getting the details of why it's harder, but trust me, it is, and you don't want to do it that way. But what is the easy math way? Nobody, huh? Okay, well, going on to the next problem then. Nobody knows anything. All right. Just kidding. Just kidding. Here we go. It's easy. You just do 18 plus 54 over 60 plus 36 over 3,600. Does that sound familiar? Yeah, and that's how you want to go from DMS to decimal degrees. And then you just type that in and hit enter, and you get 18.91 degrees. And then here is the work for the next one. And let's go on. Okay, trig ratio. So right triangle ABC has a right angle at B. Segment CA is 11, and segment AB is 7. We want to find sine of A, cotangent of A, and secant of C. So how should we approach this problem? What's the first thing we should do? If this was a test question, because it's going to be,
Draw a picture.
Draw a picture. Thank you. Draw a picture. Let's draw a triangle. All right, so I drew my right triangle. How should I label it? A, B, C. Which one's A? Which one's B? Which one's C? It sort of matters.
Okay, so the right angle is at B. So wouldn't the right angle here be B? Then this be CA, since that's 11.
Yep, and it wouldn't matter which one's A, which one's C at this point. What matters is your right angle B is labeled correctly. Okay. All right. And then we start labeling sides, right? So which side is 11?
AC or CA.
Yep. And then that means that AB is 7. So yeah, just draw pictures. All right, so I have I should have covered it in white. I don't know why I didn't. How do we find that other side?
The something with the P theorem that I cannot.
Yeah, the Pythagorean theorem. All right, so everyone do the math and find that side. Everyone do it quickly. I'm not going to show it on the screen. So everyone should do the Pythagorean theorem. And what do we get? Hmm. 6 rad 2. I think that's probably right. 6 rad 2. Yep. All right. So sine of A. So what we're going to do is we're going to be here. So the sine of A, we use, somebody said it earlier, SOHCAHTOA. So sine is opposite over hypotenuse. So it's 6 radical 2 over 11. Yep. Cotangent. Now cotangents, if you remember, cotangent is just the inverse of tangent. So if tangent, I'll do it above it. So if tangent is opposite over adjacent, that means cotangent is adjacent over opposite. Okay. All right, so we're still at angle A. So what side is adjacent to that angle? Yep, 7. And then opposite, we can clearly see that one. And then what do we got to do? Rationalize. Yep. So multiply top and bottom by what? By rad 2. Yep. All right. So doing that, we get 7 radical 2 on top, and we get 6 times 2 on the bottom, which gives us 12. It looks like I showed a step here. So 6 times radical 4. Square root of 4 is 2. 2 times 6 is 12. You probably could have gone from this step right to this answer, I think, pretty easily. I think it's easy to see 6 times 2 gives us 12. But if you want to show this step here, it's because it's easier to look at, go for it. It happens. All right, so secant of C. So I'm going to move we are now at angle C. So let's move my circle here to angle C. So secant, that angle, where secant is the inverse of cosine, and cosine is adjacent over hypotenuse. So that means secant is hypotenuse over adjacent. Ha. Hypotenuse is 11. Adjacent is 6 radical 2. We have to rationalize. And then there's the work, and there's the final answer. So draw pictures and make sure you know what angle your point of reference is. All right, convert. This should be super easy. So 455. So all of these we got to convert either from degrees to radians or radians to degrees. So all of you should be a pro at this by now. So 455 times what? What do we multiply that by? Pi over 180. Yep. And we just type that in, hit enter, and we get 91 pi over 36. Negative 180. Well, multiply that by pi over 180, and we get negative pi. 7 pi over 6. We multiply by 180 over pi this time. And we do that math, and that's how we get 210 degrees. Negative 13 pi over 20 multiplied by 180 over pi, and then that's how we get negative 117 degrees. So this, in my opinion, is freebie problems on your test, converting from one to the other. This is fundamental for this semester, is converting from one to the other. And if you guys can't do these problems on this page, you are in a world of hurt this semester. Well, Emily, I wouldn't go that far. I would say just show up for class and do your work. Yeah, honestly, I truly believe anybody can learn anything. Like if you think that, oh, I've always been bad at math, well, maybe you just didn't have the right teacher, or you didn't have the right study skills. But anything anybody can learn. I really believe that. All about how much effort you want to put into something. Well, we're all bad sometimes. All right, this is also another freebie. I had this on this page. I don't know for what reason, I forget. I know there was some question on your test that asked about ratios. So I just put them all on this page. So I forget what the question was, but there you go. There's all the ratios. Okay, more questions here. All right. So think about remember the sine is y, cosine is x, tangent is y over x. So that's important for this question. So think about the unit circle, the quadrants. So where is sine positive? Which quadrants? Where is sine positive? Which quadrants? So my question to all of you, sine. Sine is what variable? Y. So I'm asking you, in which quadrants is the y value positive? 1 and 2. Yep, 1 and 2. So if it helps on this problem, so I have these 3 problems on this page. So I can promise you that you won't have these 3 problems on your test. You're going to have other problems like this on your test that you're going to have to think about. So I just have these 3. I didn't want to put anything you're going to see on your test, the exact questions. So if it helps, when you see sine, cross it out and put the y variable. Because that's what I'm asking you. Where is the y value in the coordinate positive? And it's positive in quadrant 1 and 2. Y is positive in 1 and 2. Y is negative in 3 and 4. All right. Where is cosine negative? Where is cosine negative? Where is cosine negative? It is 2 and 3. So cosine is what variable again? Cosine is x. So I'm asking you, in which quadrants is the x value negative? And x is negative in quadrants 2 and 3. So something else that you can do on your paper is write your x and y coordinates, and then x is positive, y is positive, x is negative, y is positive, x is negative, y is negative, and then x is positive, and then y is negative. Maybe drawing that diagram will be better. Magic. I know it's math magical. Mathemagical. All right, so cosecant. Where is cosecant positive? Now, if you remember, cosecant is the same thing as 1 divided by what? 1 divided by y. Yeah, so 1 divided by y. So remember, cosecant and sine are inverses, so cosecant is 1 divided by sine, and sine is y. So again, I'm in a way I'm asking you, in what quadrant is y positive? So which quadrants is y positive? Yeah, 1 and 2. So in a way, on this page here, this first question and this third question are more or less asking you the exact same thing. They want to know which quadrants y is positive. It doesn't matter if it's a fraction. All right, last one here on this page. Where is cotangent negative? Where is cotangent negative? Two and four, I think, sound right to me. So remember, cotangent is the same thing as x over y. So tangent is y over x, cotangent is x over y. So in order for you to have a negative cotangent value, either the x or the y need to be negative. And that occurs only in quadrant 2 and in quadrant 4. One of them has to be negative. So quadrant 2 and 4, that is true. So for these, I would draw a diagram. I would draw a picture. Rewrite, if they're not fundamental trig questions, rewrite it in terms of, well, like we did here, 1 over y and x over y. Make sure you write the equivalent. And I think you had these on your quizzes. I'm pretty sure you had them in your learn and practice modules. So some questions that appear on your test, you should have seen at least once or twice going through the problems and the modules, which are required, by the way. It's good practice. All right. We got about 10 minutes left. We got to hurry up and get through this. All right. The terminal ray of angle beta drawn in standard position passes through the point -8, comma negative radical 17. What is the value of sine B? All right. So drawing a picture is good. So this is in quadrant 2. So if I draw this here, -8, so over 8 and then up, or sorry, down. I'm sorry, it's quadrant 3. Sorry, not quadrant 2. So it's going to look something like this, right? So that's the coordinate -8, comma negative 17 or whatever. It's obviously not drawn to scale. So the x value, this is -8. This is negative radical 17. There is the right angle here. And then there is that is the angle beta. So we need to do the sine. Now sine is opposite over hypotenuse. So you have to calculate your hypotenuse by doing the square root of a squared plus b squared. So for these problems, you want to draw a picture, you want to label stuff, and then we'll probably have to calculate the hypotenuse. And the hypotenuse is going to be the square root of -8 squared plus negative radical 17 squared. And don't forget your parentheses. If you forget those parentheses, your answer will probably be wrong. So everyone type that in and tell me what you get for the hypotenuse. Nine sounds right, maybe. It is 9, yeah, so that is 9. So yeah, that's 9. All right, so that's how we get sine of beta. Sine is opposite, so it's negative radical 17 over hypotenuse, and we found it to be 9. That's why 9 goes here. And do we have to solve? Why is that box there? Oh, so I put the negative in front because your answers, when you type them in, they want the negative in front of the fraction, not in the numerator like I like it. So that's why I wrote it like that. You're right, it doesn't. It doesn't. All right, so the next example here, similar problem. It gives you a coordinate, so we like to, draw pictures, right? So it's -2 and then up radical 5. So I'm just going to put a point here just to show it's in quadrant number 2. So this is -2x, and this is radical 5 for the y value. And then this is your angle beta, and the cosine is adjacent over hypotenuse. So again, we have to find the hypotenuse, the radius of this circle. So it's the square root of -2 squared plus radical 5 squared. All right, type that in, hit enter. What do we get for the hypotenuse? It's probably 3. I think you're right, Antonio. I think it is 3. Type it in, you should get 3 if we know how to math correctly. So that means the cosine of that angle is -2 divided by 3, I think, right? Yeah, it is. Yeah, adjacent over hypotenuse. And again, it likes the negative in front, so there you go. So one thing I want to point out in this problem, the question says, what is the value of cosine beta? It doesn't ask you what is the value of beta. It doesn't want to know the degree. It just wants to know the trig ratio of what it equals. So if this problem says, what is the value of angle beta, then yes, you would inverse cosine both sides to find your actual degree. But this one actually wants just cosine of beta. So it wants the trig ratio. Hopefully that's clear. All right, coterminals. This is also a freebie question. It's going to, I don't know if it's going to have like, is this true or false, or you get to type in your own. I'm going to guess it's going to have a list of degrees, and it's going to ask you, select the ones that are coterminal angles. So remember, coterminals, you either add or subtract 360. So I have 3 examples here just to show how we can get 3 different angles. So we can add 360 to get 450. We can subtract 360 to get negative 270. I can even add or subtract 360 more than once. So in this case, I added 360 twice to get 810. So all of those degrees are coterminal angles. By the way, some of you have learned from the quiz that you can't have, so 90 degree isn't a coterminal angle of itself. That's just the same angle. So you can't count 90 as a coterminal angle because it's the same angle. Some people message me about that. I don't think your test will trick you like that, but on the quiz it did. All right, special right triangles. On this page, I have the right triangle itself, the 45, 45, 90. Down here, I have the 30, 60, 90 triangle. So to find, we want to find the length of the hypotenuse. So looking at this formula, going from side to hypotenuse, multiply by radical 2. So, yep, 3 radical 2 is the answer. Second one here, I give you this stuff. We want to find the hypotenuse. It is easier going from the leg coming off 60 degrees because we just have to multiply by 2 going from leg to hypotenuse. So it looks like I give you the leg coming off the 30 degrees. So going from the 30 degree leg to the 60 degree leg, I divide by radical 3. So divide this by radical 3, I just get 8. So this leg is 8, and then going from this leg to the hypotenuse multiplied by 2, and that's how we get 16. All right, we are almost done. We got about a minute or 2 left, so let me make this quick. The last slide, what's up? All right, TGA number 1. The hypotenuse of a right triangle measures radical 69 centimeters, and its shorter leg measures 2 radical 5 centimeters. What is the measure of the larger acute angle of the triangle? Round your answer to the nearest 10th of a degree. So remember, 10th is 1 decimal place. Do not mess this up. I will mark your entire problem wrong if you do not round to 1 decimal place. Also, round correctly. If you don't round correctly, if you're off by a 10th of a point for your degree, I will mark it wrong. So draw a picture. Label what it's telling you. It wants to know the angle of the larger acute angle. Definition. What is an acute angle? I said it once during one of the lessons. What is an acute angle? Think back to geometry. An angle less than 90 degrees. Yes. So in a right triangle, not counting the right angle, are both angles acute angles? They have to be, yes. Yes, both, not counting the right angle itself. Yes, both angles in a right triangle must be acute. So I want to know what is the angle of the larger one. So out of the other 2 angles, what is the angle of the larger one? I'm not trying to confuse you, but that's what it's asking. So I've already said enough, more than enough to help you do this problem. This is a very simple problem. show your work, take a picture of it, put it in a Word document, save it as PDF, submit. If you just give me an answer and you don't have work, I'm tired of receiving some submissions with no work. It's only a few. It's maybe like 5 people like to submit answers and no work, and I'm just like, I don't know what you're doing. Next one. Corey spies a bald eagle in a tree. He estimates, hey, who wants to read this? I can't read. Who wants to read this out loud for us?
I can read it.
Go for it, Julia. I think it's you.
Nope, this is Katie.
Who is it?
Okay. It's Katie.
Oh, Katie. Okay, thank you. Sorry.
Sorry, I never use mic. Okay. Corey spies a bald eagle in a tall tree. He estimates the height of the tree to be 60 feet and the angle of elevation to the bird from where he stands to be 64 degrees. The leaves on the tree make it difficult for Corey to watch the bird, so he takes many steps away from the tree to get a better view. He now estimates his angle of elevation to be 37 degrees. How many feet did Corey step back to gain a better view of the bird? Round your answer to the nearest hundredth of a foot. No work equals no credit.
Thank you. Thank you so much. So this problem, unlike problem number 1, wants hundredths of a foot. So that's 2 decimal places. Don't mess that up. I want 2 decimal places. So when it says he takes many steps away, I'm going to give you a hint. It's more than 20 feet, but less than 100. So it is many feet. Okay. So somewhere between 20 and 100. How about that? There's something to help you out. So if your answer is not between 20 and 100, it's wrong. For the final answer, we steps back. So this problem, draw a picture. And this problem is actually, don't overcomplicate this problem. This problem can be done very, very easily. There's a really hard way to do this problem, and there's a very easy way to do this problem. So I don't know if you had a problem like this in your modules, like your learn and practice modules may have had something like this, but there's an easy way to do this problem, and there's a very hard way to do this problem. All right, number 3. We did this yesterday. So I give you this fraction here of trig functions, and then I need you to do the math and give your answer in simplified radical form. Just like yesterday, I want to see work for all of these individually. So I should see you write, oh, tangent of negative pi over 3, and then here's all my math to get my simplified answer for that. Cosine of 3 pi over 4, there's all this work, there's that answer. Cosecant of negative pi over 2, there's this work, there's this answer. Once you have all 3 of those, take those answers, plug it back in like we did yesterday, and then simplify that. That's what I want to see for this number 3. And I better see work. All right. So I would say this one's probably going to take, well, this one might take you the most drawing work, but the math is actually pretty short if you do it the smart way. This one's not too bad either. This one has quite a few steps too, just because you have 3 trig functions to solve for first, basically. All right, password. Anybody want to guess what the password is? Nah. The password is SOHCAHTOA. It is case sensitive. The S, the C, and the T are capitalized, and then you have an exclamation point at the very end. Yep. All right. Well, part 1 of the test is today, if you have time. Part 2 is tomorrow, and then that means on Thursday we are starting unit number 3. I know, exciting. All right, everyone. Good luck. Who's drawn? Elijah, you monster. And yes, I can see who draws on the board. Sarah, I see you. All right. Till next time.